Welcome, everyone, and we'll get started. I'm David Dixon, a meteorologist and TV engagement coordinator with the nonprofit covering Climate Now. I am so happy to see you all here today. And for those that might not be aware, Covering Climate Now is a global collaboration of more than 500 newsrooms. We're organized by journalists for journalists, and with the goal of just keeping us in tuned and to do better climate coverage of this global crisis and its local impacts. You can head over to our website, coveringclimatenow.org, to learn more and sign up for our newsletters and newsroom trainings, all of which are going to be free of charge. I'm thrilled to be joined here by a fellow meteorologist and a colleague of mine who will help moderate today's discussion. Shel, over to you.
Yeah, thanks, David. My name is Shel Winkley. I'm a meteorologist as well as the weather and climate engagement specialist at Climate Central. If you're unfamiliar with us, we're a nonprofit and we're a non-advocacy organization of scientists and communicators dedicated to researching and reporting the facts and impacts of climate change. At Climate Central, we develop and distribute just different resources for broadcast ready, journalism ready, publish ready content to help you, helping to empower your forecasts, your stories, and your content to make the critical link and the crucial links between extreme weather events and the human-caused climate change to your audience, to your viewers, to your readers, just really helping you tell those localized stories.
Thank you again, Shel. And once again, thank you all for joining us for this first Prep Your Climate coverage session. It's going to be a seasonal series dedicated to providing resources and accessible language that you all can use when covering the upcoming season's anticipated climate-driven extreme weather events. This session will highlight emerging climate research and spring severe weather, including tornadoes, hail, flooding, explore how journalists that we have gathered here today have reported on the human impacts of these events, and offer vetted language that can help you in your own reporting. It's often that we see that climate coverage is reactionary, often with journalists and reporters scrambling for relevant information and relevant resources and information like that in the aftermath of an extreme weather event. Our goal for these sessions offered in the spring, summer, fall, and winter is to get ahead of this so we can move more quickly and effectively make the climate connection in our reporting before these storms and other impacts occur. You'll be happy to know that this webinar is being recorded, with the video and recap being made available to you all and your colleagues that were unable to make it today, so don't need to take notes too much. We'll also have plenty of time at the very end for some questions. Go ahead and submit yours via the Q&A button at the bottom of your screen, and be sure to include your name and the outlet that you work for. I'll read them out later for our panelists to answer. And while this webinar is open to everyone, please know that we're going to be taking questions from working meteorologists, journalists, and newsrooms only. Now, it's my pleasure to introduce our panelists who will help Shel and I today. Please give me a warm introduction to all of them. We have Dr. Maria Molina. She is an assistant professor within the Department of Atmospheric and Oceanic Science at the University of Maryland in College Park. Before her career in academia, Maria worked as a broadcast meteorologist on national cable news. Thank you for being here. We also have Kylie Price, a reporter at Inside Climate News and writes their Today's Climate newsletter, which I highly recommend, which covers the most pressing environmental news each week. Her work has appeared on National Geographic, Time, Scientific American, and many more. Please join me in giving both of our colleagues, along with Shel, a warm virtual welcome. So let's go ahead and get started. We got a little bit of climate housekeeping, if we want to call it that, before we move on, because I want to quickly review the difference between climate and weather. To the meteorologists and the climate reporters in this room, this may seem pretty obvious, but it can lead to real confusion for many in your audience, your viewers, your readers, and that's really an important thing to tackle ahead of time, because especially when we're talking about extreme weather events and the climate implications of them, it's important to know this distinction. In a nutshell, weather refers to the atmospheric conditions that exist at a given place at a certain time. We're talking about weather when we say it's raining today, or it's nice, or it's hot yesterday. Climate is the long-term pattern in weather conditions over time. So we're talking about climate when we say Texas is usually hot in July. One analogy that I like to use is weather tells you what clothes you should wear today, climate tells you what clothes you should have in your closet. What we're going to be talking about a lot of today is going to be weather, hail, tornadoes, etc. But we are going to highlight the climate influence on long-term trends of these severe weather events so you can more eloquently and effectively make that link between climate change and weather in your reporting. With that bit of background info out of the way, let's go ahead and dive straight in, beginning first with hail. Over to you, Shel.
All right, thanks, David. Yeah, let's start with the hail of a topic here. Hailstorms. They are by far the most costly hazard associated with severe thunderstorms and severe thunderstorm season. You can see it there in the graphic, just how the risk is across the country and especially across the central portion of the United States. Hailstorms with these thunderstorms, they cause about $10 billion of insured losses each year in the US. And look, we haven't even started accounting for the agricultural losses in that price tag. So that's before you really get into what this is doing to our agricultural communities, our farmers, our ranchers. That can run into the billions. For businesses that are relying on crop production, a hailstorm can ruin an entire season's worth of income. And while tornadoes do get most of the attention, that's what fills our screens the most sometimes during severe weather coverage. It is hail that is becoming a bigger issue for many areas, with hail damage exceeding the costs caused by tornadoes, lightning caused fires, straight line wind events, all combined. So in the past decade, we've seen several instances of single hailstorms causing over $1 billion in damage in states like Texas and Colorado and Minnesota, even further north when you get into places like Canada, specifically in Alberta. Unfortunately, research finds that large hail is becoming more common in a warming climate. And so to dive into the science of that, because when you think about hail, which is a giant piece of ice, you don't maybe necessarily think about that in a warming climate. So let's bring in Dr. Maria Molina to discuss this, because at first it seems kind of counterintuitive. So I think maybe that's where we start. Dr. Molina, can you explain how hail forms for us, just in the general sense, for maybe the folks in the room that don't know that just yet?
Yeah, absolutely. I really like that figure that you shared that showed a lot of hail damage activity across the central US. And that's because that's one of the parts of the country where you have all of these ingredients coming together to form intense thunderstorms that can lead to very large hail. But generally, the way that hail forms is we have a thunderstorm that has an updraft. So there's daytime heating throughout the day, a lot of moisture and heat occurring near the ground, and that warm and less dense air rises, creating a thunderstorm updraft. As that air keeps rising, we then have water that is entering the supercooled state. So tiny little droplets that are very cold, not yet ice, but are at temperatures that are below freezing, very high up in the atmosphere. Eventually, you have these supercooled water droplets coalescing or attaching to ice particles and other aerosols and dust and such particles that are in the thunderstorm cloud. And there's growth that happens through accretion as these supercooled water droplets are attaching to the very small ice pieces. And some of these pieces of ice, as they're growing, can get stuck in an updraft multiple times. So they might grow over time, start to fall down due to the pull of gravity, but then get stuck in the updraft, and sort of this recycling happens with that piece of ice continuing to grow over time in the updraft. Eventually, it will get too big to even have it be suspended by an updraft, and that's when you have that piece of ice coming down and unfortunately producing damage like you indicated there in the figure.
I think just being a weather nerd myself and a meteorologist, I think one of the coolest processes is super cooled water. Like, that's just cool that you can have water that's at or below freezing. Okay, so a warmer climate, right? We know that there is still cold in the world. A lot of the United States just experienced that. So there is still cold air to work with here. But how does this warming climate and climate change lead to these larger hailstones and bigger hail events?
Yeah, so the way that severe thunderstorms are impacted by a warming climate is quite complex. You have these opposing trends that either can lead to more intense thunderstorms or then can counteract certain effects and potentially lead to reduced impacts from severe thunderstorms. So to think about the items that would land on the more intense severe weather, that includes warmer temperatures. Warmer temperatures can hold more moisture in the atmosphere, so therefore you would have more instability and rising air and convection that's occurring. So that would be sort of a plus sign on the more intense, right? More moisture, more potential for thunderstorms that are intense. That can also lead to stronger updrafts because if we have warmer temperatures, more moisture, that's less dense air near the surface, that's going to rise with more power. So stronger updrafts, another plus on the more intense potential for severe weather. If we have stronger updrafts and more moisture, that can also lead to extended growth time for hail. So maybe hail that gets stuck in updrafts for a longer period of time and can grow even more so, and potentially also higher cloud tops as that updraft continues pushing upwards, and also more frequent storms potentially. However, then you have on the other side things that will counteract that positive trend. One big factor, for example, is if we have warmer temperatures, that means that the point at which hail starts to melt as it's falling is going to increase. So there's going to be more melting as that hail is coming down and potentially leading to a smaller hail size by the time it gets to the surface. Another really important ingredient for severe thunderstorm formation is wind shear, which is winds moving in different directions, either in the horizontal and also in the vertical. And what that does for a storm is support its rotation and let it live longer because you don't have the rain kind of tainting the updraft portion of the storm that's so important for its growth and sustainability, I guess. And so that is something that can end up hindering the intensity of storms. So again, if we don't really have a good handle on how wind shear will change in a warming climate. And so if it ends up being that we have less wind shear, then we would have a counteracting force on the potential increased frequency in severe weather due to a warming climate. That said, there have been quite a few studies that have explored this really difficult question, not only on hail, but also tornadoes and what that means for a future climate. And we know that there are shifts in the spatial probability of where we can see more storms or fewer storms, not only across North America, but also in the world.
Perfect. So, and we'll talk about tornadoes because that shift is something that is very much being witnessed right now. We'll come back to that, but let's talk about that hail potential, right? So we saw that corridor in the central U.S. that had the highest risk of hail. Is that shifting? Should we be looking, elsewhere where people maybe aren't quite as used to these big hailstorms? Is that changing as climate change takes hold?
Yes, I would say studies have shown that generally we're seeing an eastward trend in severe thunderstorm activity. You have very warm temperatures in the Gulf of Mexico and a lot of moisture flux moving northward, and therefore that's one contributing factor to the potential for more severe weather. So the southeastern United States is a part of the country that does deal with severe thunderstorm activity, typically during the winter season, which is a little unusual when we think about severe weather. But we're starting to see those ingredients that are more favorable for severe weather across the central US kind of shifting eastward over time, and where we would be traditionally seeing during the spring severe weather in the central US, that could be shifting eastward. And so that can also lead to changes long-term in the seasonality of severe weather, where we could have storms that produce severe hazards occurring earlier in the season as well. So not just space, but also time of year.
Right. I appreciate it. Thank you. We'll take a break for just a second there on that. And, it's really worth looking into these areas that are most at the front line of some of the biggest emerging climate reporting. And it's something that gets talked about especially a lot, especially after last hurricane season too. And after the fires in LA, home insurance. Climate change is driving higher rates, limiting coverage. And in some states, insurance companies are pulling out, citing an increased lack of profitability. I'm here in Texas, and between last year and this year, our rates doubled because of what they cited as extreme weather here in my part of Texas. So that is something that you can look into. A couple different things we want to do, as David mentioned, is some language that you can use in your reporting as you're covering hail, things that you can know that is confidently science back. So this is some of that language around hailstorms. They inflict billions of dollars in damage each year, and this threat is growing as human-caused climate change makes large destructive hail more likely. And as Dr. Maria Molina just mentioned, also changing where that hail is happening. And we want to give you some story sparks or some coverage ideas that you can take and think about as we get into the severe weather season, as we get into the spring season. Some of the things we're recommending is how hail is impacting those home insurance rates in your areas, exploring resilience solutions for residential homes, for agriculture. And, I think one that really resonates with me for solar farms and personal solar panels that are at risk of being damaged by this increasingly devastating severe weather event. David, we talk about solutions a lot. One of those is renewable energies and solar panels. It'd be great to know how these hailstorms are impacting those resources as well.
Absolutely. And if you really want to dive into this, I highly recommend looking into the home insurance numbers because, as Shell mentioned, many of the states that insurance companies have pulled out of, you expect in some areas like Florida and California, but for a lot of them, it's because of hail damage, which is very, very surprising, and definitely dive into that. Thank you again, Shell and Maria, for diving into this. Again, we're going to come back to them in a moment as we talk about tornado activity and how that's shifting, but we want to take a little bit of a break, head into something else entirely, and that is going to be flooding. Remember, we're going to have plenty of time for Q&A for our panelists. Go ahead and continue using that Q&A function at the bottom of your screen and ask questions. Keep them coming because we love to see them. So let's go ahead and move into flooding. While heavy rain can cause flooding at any point in the year, it's most common outside of tropical systems, I have to say that coming in from the southeast, in the spring and in the summer. The climate connection here is much simpler. In fact, we've already heard it being referenced. A warmer atmosphere can hold more moisture. Scientists explain this using the Clausius-Clapeyron equation. This is something based in physics coming from hundreds and hundreds of years ago. I want to take a quick look at this video in which Chase Kane, NBC's climate correspondent, really succinctly demonstrates this physical fact using objects that you would find in your kitchen. Let's go ahead and watch it.
At Central Park, the 3 heaviest hours of rainfall ever recorded have now happened 3 times in just 2 years. Henri and Ida in 2021, and again on Friday. Across the country, there's been a surge of days like this since 1950. And although extreme rainfall is up nationwide, it's increasing the most in the Midwest and Northeast. And that's what we can expect more of with climate change. For every degree of warming, the atmosphere holds 4% more moisture. So if you think of the atmosphere, clouds as like a sponge holding moisture and then wringing it out as rain, as we burn more fossil fuels and the hotter the atmosphere gets, that's like having an even bigger sponge holding even more moisture and dumping even heavier rainfall.
We show this a lot in our trainings here at Covering Climate Now. It's really effective, not only that sponge, but also making the link to a local event, humanizing the event, and offering solutions. We'll go ahead and drop that full story in the chat a little bit later on. But as you saw, it is pretty easy to make a climate connection about something abstract such as, moisture in the atmosphere using physical everyday objects. We at Covering Climate Now highly suggest using something similar to that because it helps bridge a gap in that audience that may have an idea that they're seeing in their backyard, more rain, more heavy flooding, but not possibly being able to connect it to a wider global phenomenon or crisis such as climate change. So more moisture in the atmosphere is just one part of why we're seeing more flood events. And it's one part of the natural side of things. There is the human side of things as well with more urbanization, runoff, but we're not going to really dive into that. We want to take a closer look at what we're seeing in the changes in our atmosphere and in our environment. Because in addition to more intense rainfall, we're also seeing longer periods of drought. It's this hydroclimate whiplash that we are hearing from reports out in California, also here in the Southeast with Hurricane Helene. This produces dry soil, which can't soak up as much water in a short amount of time, leading to higher flood risk with more runoff. To use a sponge analogy again, have you ever noticed with a brand new sponge, the ones that are hard and like a brick, and try to run it underwater, how it takes much longer compared to the sponge that you already have next to your sink that you've been using? It's the same thing. So again, more intense rainfall, drier soils, longer droughts, and also we're seeing less snow and earlier melt. Climate Central, as you saw in that video and some of these graphics as well, have a ton of resources to help you explain how precipitation is changing in your area, your market, your DMA. We'll go ahead and put the links for those in the chat. Highly recommend checking them out. But let's go ahead and take a little bit of a Q&A to better understand how to cover flooding, which is the second leading cause of weather-related deaths in the United States, second only to heat. Let's go ahead and bring in journalist Kylie Price. Kylie, thanks again for joining us here today. What we want to really look at as we head into the spring is we know that climate change disproportionately impacts those who are less equipped to handle its impacts. But how have you focused on the personal impacts and humanized this unnatural disaster?
Yeah, definitely. I think first and foremost, obviously, extreme weather events can be incredibly traumatic for people who experience them. So I would always recommend leading with compassion in these cases. Like, you might put a bunch of requests out for people to talk to you and only get one person who wants to share their story. That being said, a lot of people do end up wanting to talk about it and learn about it. And you kind of have to give them that platform to be able to do so. So I think with flooding in particular, obviously this year has been a lot of flooding and a lot of opportunities to cover it. And the way that I often approach these situations is by looking into community forums, and that can take a lot of forms. So like if you're doing local coverage, you can attend community meetings and things like that to see what people are concerned about, what people are experiencing, and kind of fired up about. But that can also take the form of social media. So a lot of what I've been seeing when these extreme weather events happen are things on Twitter or Blue Sky, or especially Reddit, actually, where people seem to feel a little bit more comfortable. And that doesn't always mean that you're going to get a source out of that, but you might be learning what people want to know more about. So in the newsletter, for example, it kind of, you get a sense of where people want coverage to be heading, and then you can go ahead and find some sources who might be able to talk to you about those situations, like Maria, or somebody who can offer that scientific perspective on these things. So I think explainers are really helpful in these times and make people feel comfortable, because knowledge is power in a way. But I think with flooding in particular, it's important to just realize how many different aspects of life flooding can touch. So yeah, with inland flooding, that was really interesting during Helene. I actually was able to talk to a hurricane researcher who had moved from Louisiana to Asheville to escape hurricanes. And then obviously Helene hit Asheville really hard. And he was able to offer some perspective on, both sides of things, the scientific side and also the experience of going through that storm. But yeah, I think insurance is a huge one, like you've mentioned. That's something that everybody is being impacted by right now. And flood insurance is unique too. So it's a totally different arena than insurance for a lot of other things like the LA wildfires. But you can also look into a lot of public health impacts. And this is something that community members are experiencing themselves as well. And I find that people want to be able to talk about things in this space, and flooding especially, you have all this water present and it's just kind of sitting there for weeks on end. So being able to offer, explanations behind why this stuff is happening, I find that it's really helpful for readers. And I'm fortunate that I write our newsletter, Today's Climate, and I have kind of a direct channel to readers, and I'm able to ask them what they want to learn more about. But I think that you can also put that out on your social media channels and say, like, what do you want to know about with this storm that just happened? Or, what storms could happen over the next few weeks or months or anything like that. So yeah, I hope that gets at some of the answer for your question.
Absolutely, because we at Covering Climate Now really do suggest diving into what your readers and what your viewers want. You know your area probably very well, but there's going to be a lot of individuals that have maybe lived in the area or maybe live in a part of the area that you may not know about a specific impact of climate change that you want to get highlighted. You mentioned the public health aspect of this, and this is a huge thing with flooding. We know that the impacts of flooding linger long after the floodwaters recede. And you've actually covered this in a previous, some of your previous reporting. Can you talk a little bit more about these public health risks that communities are seeing in these climate-driven events, whether it's from increased bacteria, but also disease coming from this switch from dry to wet?
Yeah, definitely. I mean, right off the bat, when you have an influx of water into a community, there are so many risks that can associate because I was just in New York City the other day, and obviously the streets sometimes cannot be the cleanest. So imagine a bunch of water all at once coming onto the streets, and now all of that garbage, debris, etc., is in the water that you're walking in or something like that. So yes, I've definitely covered kind of the lingering effects of those kinds of things sitting in the water. And yeah, that's something that people are researching. So you can do it at a high level. It's also happening with like oil companies, for example. In the Gulf, with flooding, that's not as much in the spring, but with hurricane season, there have been a bunch of oil spills, chemical hazard spills, things like that, that communities are feeling the effects of, and they want to talk about it. So that's another way to find sources too, is through nonprofits and community groups have been established to kind of fight against some of these spills and things like that. Longer term trends too. So when floodwater is sitting stagnant for a long time, sometimes this can actually increase the risk of like pest-borne diseases, like mosquito-borne diseases. They've witnessed like dengue, malaria, things like that, especially in Florida, when stagnant water is sitting for a long time. I've also talked to people about, the issues with insurance and mold. So when they wait a long time to get insurance money after a flood, that increases the risk of mold. So then they have to contend with that as well. So I think zeroing in on that effect too. So some people might end up getting the money, but then it comes so late that they have even more impacts on their home. So yeah, I think there are a lot of health risks that you can zero in on, especially for communities who may be lower income or be disproportionately impacted and don't have as many resources to be able to like address this and address it immediately.
Thank you so much for all of these tips and also some great story ideas. We at Covering Climate Now really emphasize that the climate story is not just a weather story. The fingerprint of climate change and these impacts from these extreme weather events hits every beat in a newsroom, whether it's public health, whether it's home insurance, whether it's infrastructure. And we're going to dive into that in our Q&A in just a little bit. But thanks again for dropping that in. Here again is some vetted language from us here at Covering Climate Now and Climate Central that you can use in your reporting and be confident to make this connection, this climate connection, when we see these flood events that we are going to see in the upcoming season. So once again, here is that language that you can use. As our climate warms, the most extreme rainfall events become more frequent and more intense across most of the world. We've already talked a lot about the potential story ideas that we recommend diving into, exploring displacement and climate migration. There is some really great stories coming out of the Texas Tribune talking about areas that are now virtually unlivable because they're seeing too many days of flooding and its impacts. Again, highlight mitigation strategies, and explore how local lawmakers are pushing for measures to address this climate-fueled flooding and even the loss of history, such as the loss of Black cemeteries in the South because of this increased flooding. We're seeing a lot of reporting out of that, really effective reporting from our colleagues at Floodlight and also Inside Climate News. One last thing before we move on to tornadoes, which I think a lot of you are really going to enjoy because it's got some really in-depth trends to it. One last thing I highly encourage you to explore for flooding. Explore how more frequent flood events are undermining our transportation systems. A recent study released by the nonprofit First Street found that 2 million miles of road, that's roughly a quarter of the roads in the United States, are now at risk at becoming impassable during flooding events, which are now becoming more common due to climate change. That's not only impacting our supply lines, but even commutes and people that are trying to get out of their neighborhoods, even if it wasn't potentially flooded, how they would be potentially able to get to resources, hospitals, and groceries. So one last thing to really dive into. I want to go ahead and pass it over back to Shell as we take a look at tornadoes.
Yeah, David, that was good. You know, one of those impacts of not being able to get out of your neighborhood when there's a lot of flooding is for kids trying to get to school. We talk about how climate change disrupts education for our youth, and that's one of those things is that their property, their houses may be fine, but getting to school may not be possible because their ways out are cut off. Okay, so let's talk about tornadoes. It is the thing that catches the most attention when it comes to severe weather. We always say that the way that people experience climate change is through extreme weather, be it themselves, unfortunately, or through the small screen that they know that is their phones or through their TV screens or wherever they're taking in this information. And recently, it even makes headlines as one of the biggest blockbuster movies, which of course was Twisters. So let's talk tornadoes. Climate change influence on tornadic activity is, like hail, a bit tricky and a bit complicated for reasons that we'll get into here. But observational trends, when we look at the long-term trends, it also shows that tornado outbreaks have become, as Dr. Molina was talking about, migrating eastward with a severe weather season. From Texas and Oklahoma, places that we traditionally call Tornado Alley, to the east, towards places like Tennessee and Alabama over the last 30 years. We've got plenty of colleagues in Nashville that have covered their fair share of tornadoes in a very short amount of time in the last couple of years. Additionally, the overall number of tornadoes each year hasn't changed much since the 1970s, but the research does show that tornado outbreaks, or the days that we have multiple tornadoes, are becoming more frequent. And not only are we seeing a change in where the tornadoes occur, but also when. Another thing that we touched on a little earlier, research suggests that the potential for nocturnal tornadoes may continue to rise with future warming of our climate. Nighttime tornadoes, those tornadoes that are occurring between sunset and sunrise, are almost twice as deadly as daytime tornadoes, twice as deadly. That's alarmingly, while those daytime tornado fatalities are decreasing, the nighttime ones are on the rise. I don't know about you, but when I put my phone on the charger at night, it automatically goes into do not disturb mode. And so there's a chance that a lot of people just aren't getting the alerts in that way because they're asleep. They're not plugged in and paying attention. This heightened danger is particularly pronounced in the Midwest, the South, the Southeast. We're talking states like Missouri, Mississippi, Kentucky, Arkansas, and Tennessee, experiencing over 40%, and in Tennessee, that's 45% of their tornadoes at night. So what is the climate link here? One thing we know is warmer waters in the Gulf of Mexico is allowing more of that moist, warm, unstable air, which fuels these storms inland. Conditions favorable for supercells, those intense rotating thunderstorms, and tornadoes not only changing in location, but as Dr. Molina mentioned, also expanding in seasons. Milder winters mean more tornadic activity outside of your typical quote unquote severe weather season. In early spring, when people may be more in tune or paying attention to what they know is like the classic storm season. A lot of us, though, especially in the South, cover that second season when we start to see the possibility of tornadic storms again. I want to bring back in Chase Kane here and show you, highlighting climate change's influence on a single tornado is extremely difficult. But as he explains, this climate reporter with NBC, very eloquently in less than a minute about this. So let's go ahead and take a look.
The U.S. has more tornadoes than anywhere else on Earth, more than 1,000 every year. They can strike with only a moment's notice.
Oh my gosh.
Compared to other weather events, tornadoes are geographically small and brief. And computer models, which simulate the effects of climate change, you can think of them like a fishing net. It has holes, so it's only going to catch fish of a certain size. In this case, it's weather events which are larger or longer lasting, like a drought, heat wave, or a hurricane. And if a tornado is as small as a pin, then a climate model is going to struggle to catch them. But research is still showing connections, like when tornadoes form, where they form, and from more intense supercells, the storms which often produce tornadoes.
Never underestimate the things that you can find in your home to take into your reporting to really tell those stories. And I think a lot of us know that. Since 1980, March and April tornadoes have become more frequent, with increases of 36% in March and 67% in April. All of these factors make a very clear case why it's important to highlight global climate change and bring it locally to your communities ahead and during the severe weather season. The relationship between severe weather and climate change, again, like hail, Dr. Molina, very active area of research and still something that we're trying to understand, as Chase mentioned, because these are very small scale events on something that we're talking about, which is large scale, which is climate change. So let's just start there. If you don't mind, how does a warmer climate influence tornado season? And does it necessarily mean more tornadoes or more tornadoes in one place or less, or what's that relationship there?
Yeah, I want to be very clear that indeed the potential for severe weather, whether that be large hail or tornadoes, is increasing. And it can get a little complicated when we start looking at regional or very local trends and those such factors, but we know the potential is increasing. And the reason the potential is increasing is because with warmer temperatures and more moisture in the atmosphere, that leads to more potential instability. And if a thunderstorm starts to develop and can tap into that instability, that can lead to a more intense thunderstorm. But like all things weather-related, things are very complicated, and we have other factors that are very important in the development of severe thunderstorms, such as wind shear and that rotation of thunderstorms, a factor that's critical for tornado development. If a thunderstorm is not rotating, if we don't have that vorticity in the atmosphere that can lead to tornado development, you may have a thunderstorm, but you may not have the associated severe thunderstorm impact like a tornado. So again, overall, that potential is increasing with warmer temperatures, more moisture, more instability that occurs quite frequently over the central US due to the Rocky Mountains to the west that has a lot of heating at mid-levels of the atmosphere that moves eastward, creates this sort of cap over the central US that suppresses thunderstorm development until the very late afternoon and evening hours, when then we get explosive thunderstorm development. And if you've got that wind shear ingredient in there and those storms start rotating, then you've got tornadoes and also potentially very large hail. So the potential is increasing. The fine scale details can get in the way of us deciphering those longer term trends and being able to say a statement that applies everywhere, right?
Yeah, and that's a good point, right? Because again, that's the weather side, and then how are we tying in that climate change aspect as well? So let's talk about that longer scale trend. And we know that while one individual storm, one individual tornado is tricky, we do see this shift to the east of severe weather, of hail producing storms, of tornado producing storms. So do we think that Tornado Alley potentially could shift east from what we traditionally know? And then what kind of challenges does that bring for our communities, say, east of the Mississippi River?
Yeah, absolutely. We've had research that has shown that the area that is susceptible or experiences a lot of severe thunderstorm hazards is shifting eastward, which means now the southeastern US and areas like Tennessee and so forth that don't typically experience a sort of canonical or what you think of with severe weather and Tornado Alley, they're now starting to experience these impacts a bit more frequently. And the reason for that is that you've got these ingredients shifting eastward now, they're expanding, and now other areas are starting to see these severe thunderstorm hazards potentially also earlier in the season. Another issue that is human a human element is that we have suburban sprawl, which means that now areas that can experience severe thunderstorm impacts are increasing. So that's another factor, right? If we have larger suburban areas, population is increasing, and now you have more areas that can be impacted by severe weather as those storms move through. So that's sort of like a human element that is just because we're in the way. Yeah, and then there's of course the nocturnal aspect, but I'll let you bring that up later.
Yeah, no, let's talk about nocturnal, because I remember, when I started in TV, my broadcast career, I started in the panhandle of Texas. And we used to go and set up on the dry line and wait for that convective temperature to hit, that perfect temperature where storms could form. And we take a football and we pass it back and forth until the storm started going. So you think about springtime storms and severe thunderstorms, you think about it coming with the heat of the day. So what's changing here with climate change? Why are we seeing more nocturnal storms? Are they lasting longer, building during the daytime and still be staying tornadic into the evening? Or what's happening here and what's the greatest concern with these nighttime tornadic storms?
Yeah, thanks for this question. It's fantastic. And like you mentioned, if we have a very intense storm, it could potentially stay severe or producing things like tornadoes and large hail into the later hours as it continues to propagate or move eastward across the United States. So that is one factor that's increasing our concern. Another issue is that if we're starting to see an expansion of the seasonal cycle of severe weather, and we're seeing more severe events earlier in the spring and potentially into late winter, we also have the amount of daylight hours that are smaller. And so your potential for encountering severe thunderstorms at night also can increase. And with areas across the eastern United States that may not be properly prepared for such impacts, they may not have storm shelters, and they may not have basements because they're not typically experiencing these types of severe weather events. Now you have people that are going to be experiencing these impacts without proper protection, right? In addition to the nighttime concerns where people will be asleep, people will not know that impact is coming, you can't see that the impact is coming, and there's just greater danger.
No, that's great. And I think that's perfect to jump into some of the stories that we can cover about tornadoes, nocturnal tornadoes, climate change impact. And one of that is about just, are the places that these tornado trends are shifting, are they adequate, for places that maybe didn't have to think about building to be tornado resilient? So some of these story ideas that we can give to you, are traditional safe spaces still sufficient in extreme weather? As these events evolve, specifically more frequent tornado activity that's shifting east into areas that we know may have a higher number of manufactured homes or more trees, more densely populated treed areas. So you can't see those tornadoes like you can see way in the distance in the open plains. Are there adequate storm shelters in these areas? Has your area seen an increase of tornadoes over the last 5 years, over the last decade, or has there been a decrease? And if so, what are you experiencing in the other seasons that may not be thought about this quote unquote typical severe weather season? So again, to provide you with some science-backed vetted language from Covering Climate Now and us at Climate Central that you can work into your story as you're getting ready for severe weather season or as you're covering severe weather. We know that supercell and tornado conditions are shifting to new locations and expanding beyond the traditional season. As the climate warms, more supercells are expected in months like February, March, and early April by the end of the century. And, David, we talked about one of the things that builds thunderstorms just back to weather. It's warm temperatures. And that's something that, when you think about climate change, you think about more unusually warm temperatures.
That's exactly right, Sean. I mean, we can reminisce all we want about our time in TV and covering severe weather. One of the last tornadoes I covered during my time in TV in South Carolina happened on Christmas Eve. It was Christmas Eve at around 9 o'clock at night because temperatures were just so warm, unseasonably warm that day. And we're seeing, again, to all of your points, more activity of both tornadic activity and just severe thunderstorm activity outside of that regular season. But it kind of stems back to warming. And that heat, brand new data released this morning from Climate Central, found that over the past 55 years, that meteorological spring that we like to all talk about, that's March, April, and May, has warmed by almost 2.5 degrees Fahrenheit on average across over 240 cities. That's nearly 4 out of 5 cities now experience at least one more week of warmer than normal spring days than they saw back in 1970. Now, spring isn't the season that we see the greatest amount of warming. That's actually in winter. But as we head into spring, you got to keep a close eye on this because last spring, Climate Central's Climate Shift Index, this attribution science, which we're going to dive into in a moment because it really is going to help your reporting about the subject, confirmed that 2024's unusual warmth was driven by heat trapping pollution, again, from burning fossil fuels such as coal, oil, and methane gas. In addition, we found that 89% of the US population, that's roughly 300 million people, experience at least one more unusually warm spring day, made at least twice as likely due to climate change. And again, spring is warming across much of the US, but as we know with climate change, the impacts of climate change are different from location to location. Some areas potentially could see a positive net result as a result of the changes that we're seeing to our climate. Much of the area and much of the earth, though, is not, and it's not equal everywhere. Some areas, such as the Southwest, are seeing the greatest changes as we head into spring in terms of warming. You can see by this graphic right here, since 1970 to 2024, Reno, Nevada has warmed that average temperature by nearly 7 degrees since the 1970s. Again, while normal days of extreme heat and extreme cold are going to be present in our weather, warmer than average days are just a natural part of that, and included the number of these extreme warm days is steadily increasing. In fact, data that Shell and I just kind of dove in over the past month found that extreme record warmth is outpacing extreme cold at a rate of 5-to-1 across the world in 2024. So again, while we are going to be seeing still days of abnormally cool temperatures, we are overwhelmingly seeing abnormally warm temperatures. Simply put, the weather that we are seeing today is not the one that we grew up with. It's not the spring that our parents and our grandparents knew. And that leads to a ton of issues across the board. So that's a lot of numbers kind of thrown at you over the past 45 minutes or so. But what does this warming mean for your audience? And what does it mean for these climate impacts? We've already talked about a lot of it. It means more intense hail, larger than normal hail, destructive hail. It means impacts to flooding. It means impacts to tornadic activity. And then it goes beyond just extreme weather stuff coming down from the sky. For the Western US, it means a reduced mountain snowpack that's causing an earlier snowmelt and straining already limited water supplies. This recharges reservoirs, it irrigates crops, and supports hydropower and drinking systems. Less snow and earlier runoff can create big challenges for both our farmers and our cities. If you live out in the Southwest, out in California, definitely dive into this, especially as we head into the spring season, because we are going to see these impacts, even though the majority of the US did see a bit of a cooler winter as we look back in January. Again, but another way that we can look into this is agriculture. We have found in our training here at Covering Climate Now that oftentimes farmers are kind of the biggest supporters. They do want to talk about the changes that they are seeing firsthand because growing seasons are lengthening. We're also seeing impacts due to their frost and freeze season impacting the production of stone fruit, especially up in the upper United States, but also in areas further south where a frost event can wipe out an entire cash crop such as peaches and oranges. It's something that we really have to examine and something that is a potential story idea as we head into the spring. And then finally, as we have talked about, this increased warmth and increased moisture on the ground in terms of flooding and just more frequent rainy days, it causes all sorts of impacts with mosquitoes, and that also goes into tick-borne diseases and in general longer and more intense pollen seasons as well. There's so many potential story ideas to explore using Covering Climate Now and Climate Central resources. We'll go ahead and put those in the chat for you. Okay, that was a lot. Let's take a look real quickly at the language that you can use, because this is something that you can connect into your own reporting. Talking about spring temperatures adjusting. Spring, like all seasons, is warming across the United States, driven by carbon pollution that traps heat in our atmosphere. As temperatures rise earlier, allergies intensify, water supplies shrink, and agriculture faces increased challenges. We're going to touch on a way to show this using Climate Central's attribution tool in a moment. You'll be happy to know, for all the meteorologists in the call, this is available in a KML format that you can drop into your Max and Barron systems, and it's going to be very helpful. So once again, this was a lot of information we covered, but we want to get to some of the questions that you all have been dropping. So let's go ahead and dive into them. Let's start off with this one. Likely, I think, Kylie, this is meant for you. What tips can you offer when reporting on the unique ways extreme weather impacts rural communities?
Yeah, so rural communities can be tough to cover sometimes because of a lack of trust. So I think right off the bat, just considering everybody listening here is trying to prep their climate coverage, I think that this is a good place to start, is just by starting to build trust with these communities. So that might mean talking to people without your recorder on, or just visiting and going and seeing it for yourself. Like David mentioned, a lot of farmers and a lot of gardeners and just people living their day-to-day lives are feeling these impacts already and kind of ahead of the game when it comes to like telling you about what's going on here, and they kind of have insight that a lot of people might not who live out there. So I think trust building is important, and just like giving them a platform to listen can be really helpful, and showing that you're trying to get it right. And then when you're writing the story, I think this is a great opportunity to weave those personal experiences with scientific perspective and data and things like that, so that you can almost offer that explanation right after somebody gives their personal experience.
Absolutely. Let's go ahead and take another question. This came to us via the RSVP, which thank you all again for RSVPing for this first session in our series. It comes from Ryan Warner with Colorado Public Radio. And I think this one probably goes to both you, Shel, and Maria. How do we responsibly tie any single extreme weather event to climate change?
Yeah, I can start there. And David mentioned the climate shift index and attribution science. So for so long, we talked about the fact that no one weather event could be tied to climate change, and we still know things like hurricanes and heat waves and weather will still happen. But now with attribution science, we can understand the frequency of them, or how much more intense, right? We do that with our climate shift index on air temperature and sea surface temperature, and our hurricane attribution that we did with the 2024 Atlantic hurricane season last year. But then you have organizations like World Weather Attribution, who are taking things like hurricanes Helene and Milton and these big intense heat waves like we saw last year from Florida to Central America and Mexico. And we're able to understand that, yes, this would have been an abnormally and unusual temperature time anyway, but how much more intense and how much more likely is that going to occur as we go into the future? So attribution science is that tool. It's a way to say, okay, you're walking out the door and you're from Colorado. So knowing yesterday the temperature in Denver was warm for this time of the year, and it was close to records. Using the climate shift index, we were able to see that that temperature was made 2 times more likely. So at least twice as likely to occur because of the warming that has been caused by human-caused climate change. So it's a way to help people and normalize that conversation and just help them understand. When you walk outside and you think, oh, I didn't need this jacket today, it's kind of warm for February, help them realize that this is something, if you like a February temperature in February, with a warming climate, this is something that is potentially, at least in the way of Denver yesterday, now twice more likely because of the added warming that we've put into the atmosphere with heat trapping pollution.
Maria, do you have anything to add on top of that?
No, that was perfect. Basically summarizing what Shell mentioned, which is just an event that is extreme could have occurred anyway without the impacts of climate change, but perhaps it was more intense or can become more likely in the future due to climate change impacts.
Yeah, and just to add one more thing, what I think is really interesting with attribution science is we can say with scientific certainty how much more intense or frequent this could be with the warming that we're at, right? We're about 1.3 above the pre-industrial average. What we can also do with attribution is use that same model to then understand how much more intense a storm or whatever event that we're looking at will be with additional warming if we approach that 1.5 mark or 2 degrees above the pre-industrial average. So it's just really a way to help people understand what does that number mean and what does it mean for your everyday lives and your communities.
Yeah, attribution science is a couple things. Attribution science is not a new thing. It's been going on for over 20 years now. There's been over, I believe, 600 attribution studies done across the globe, both by World Weather Attribution and by other scientists across the entire world. I think Carbon Brief, I'll drop that in the chat, has a great resource where you can dial into all of them. And not every single attribution study finds a climate link, but the overwhelming majority do. I think it's roughly around 85 to 90%. I will say, if you are trying to learn more about attribution science, Covering Climate Now has a great resource available on our website. One thing to remember, especially when we're talking about spring severe weather season compared to things such as typhoons or hurricanes or extreme heat, not everything can be attributed to climate change in terms of a singular weather event. Often we see a lot more attribution studies and the findings from those for larger as well as longer events, such as a hurricane. If you think about it with that same thing with Chase Kane and the giant net, not only is it a larger event, but it's also a short-lived event. Tornadoes, even the ones that are long track or long-lived, it's measured by hours and not the days that we see with hurricanes. Do have a question coming to you from Barbara Moran at WBUR in Boston, talking about not so much extreme heat, but extreme cold. As we are aware that most of the United States has seen its fair share of cold snaps this winter. They were wondering, can any of these cold snaps be linked to climate change at all? Open that to the floor with anyone. I will just go ahead and flag something that Covering Climate Now has produced in terms of our locally sourced newsletter. Highly recommend signing up for that. That's available on our website. In fact, our last one just released about a week ago, kind of talks about extreme cold in the context of climate change. But Shel, I know you and I have had conversations about this, and it goes into, don't let one extreme dictate what we are seeing overall.
Right. Yeah, and we'll start there, and I'll let my colleague Lauren Casey is dropping links in the chat for you, so I'll let her do this as well. But we've had that question come up a lot, and I'm interested in Maria and Kylie's points, both one from the scientific side, one from the storytelling side, because that is really hard, right? We always hear that comment of, oh, it's cold, or we set a record low, so tell me again how climate change is real, right? Again, I brought this up earlier, but there's still cold in the world. Like, we still know that there is cold weather out there, but you have to zoom out a little bit from what people are experiencing. So look at January. While the United States generally was colder than average, zoom out, and we know that January 2025 was the hottest January of record for the planet, because most of the rest of the world was above average. We also know, yes, here in Texas, we don't get a lot of record cold. And I put this on my Twitter/X feed the other day, but we finally had a few record lows in Texas. But when you look at the data, and we've got a record tracker that we can share with you, the amount of record highs versus the amount of record lows that are occurring is outpacing the cold, right? We know that most of the records that are being set, especially since 2000, for most of our locations across the country, have been record heat. So it's good to remember that. It's good to remember the long-term trends, and also A couple of the resources we have for you that's science backed is we know our coldest days are not as cold as they used to be. They are getting warmer. We know that these cold snaps are not as long as they used to be. They are getting shorter. And this is where we can bring Kylie in. This sounds good to some people. They may think like, oh, it's not going to be frigidly cold outside. That's great. I can go outside. But winter has impacts, right? The snowpacks, the water supplies, the winter recreation. Those are the stories you can tell around these shorter cold snaps.
Yeah, I can hop in there from like the narrative perspective, but yeah, I mean, obviously people are going to use this as fodder for saying climate change isn't real. Like that is going to happen whenever it's cold, to be honest with you. But I do think like offering that explanation, like Shell was talking about, readers really respect when you're able to explain things and offer some sort of like what's uncertain here? What do we still not know? Like people want to know that too, and not just rigidly definite answers. And I also think that extreme weather in general, like cold spells, can expose inequities that also happen during heat waves. So, for example, like a lot of apartment buildings are required to provide heating during a cold spell, and they are not required to provide AC during a heat wave. So I think like you can also take the opportunity to, talk about some of the parallels with these things. And yeah, it's like one step removed almost, and just able to talk about just general inequities when it comes to extreme weather. Um, we haven't touched on phenology as much, so kind of this mismatch in, when a cold spell hits, but it was warm prior to this. We talked a little bit about it with farming. But this is a really interesting space. This is like one of my favorite things to cover is just all of the ways that climate change is throwing ecosystems out of whack. And I think that this is another opportunity like where people are asking questions. I'll just give an example. Like last year, there's this migration of spotted salamanders every year where they basically go to these things called vernal pools, and they have to cross a lot of roads to do it. And I was looking at a Reddit chain and people were saying, hey, I think that these spotted salamanders are coming out earlier than they normally do, and I'm worried about them. And so I talked to one of my sources from a scientific perspective, and I was like, do you think there's any legitimacy to these claims? And they were like, yes, they are coming out much earlier. And there's a lot of risk here because if a cold spell hits, all these salamanders are going to die. And so I think that talking about that like unpredictable weather, so like a cold spell, is really important. And it's it plays into this whole climate story.
Very briefly, just touch on that. We talk about how people see this extreme weather because they experience it or they see it through social media. Iguanas falling out of trees in Florida, right? That's nothing new, but that's one way that you can make that connection to talk about these cold spells as well. Yeah, I like that a lot.
One thing I want to flag before we head into probably one or two last minute questions. I know we're a bit after the hour. We had planned this to go until around 1:15. We understand all of you are very busy with our newsrooms and really appreciate you not only taking the time, but also the interest to expand your climate knowledge so that you can be ready and able to make these connections ahead of this spring extreme weather. I want to flag two things. One, if you haven't done so already, go ahead and sign up for both Climate Central's as well as Covering Climate Now's newsletters. And even Kylie's newsletter as well over at Inside Climate News. It is a fantastic resource, not only so you can stay on top of what is happening across the world and in your region, but also stay informed about the current research and the current findings supporting that what you are doing is what the people want to hear. We at Covering Climate Now are launching a new initiative called the 89% Project. This is based out of a recent study released in Nature that found that 89% of the world's population wants their governments to do more about the impacts of climate change that they are seeing. The notion that your audience does not care about climate change is a false one. We have seen research not only from this study published in Nature, but also from our colleagues at the Yale Climate Communications, where you can actually dive into the local scale and find out that the majority of your audience is at least concerned about the impacts of climate change. We do have the initiatives that we can use to mitigate the worst of climate change, but what has been lacking has been the political willpower to do so. And this silent majority of 89% shouldn't be that. We all want to mitigate the worst impacts of climate change. And so we encourage you to not only explore what this project means for us at Covering Climate Now, but encourage you all to participate as well as we move into the spring and move into the fall as well. My colleague Elena Gonzalez just dropped the link in our chat. Please explore that, and we hope you participate and join us. Let's go into just one more question for the chat today. It is coming from Justin Walker. Can you tell us more about the consequences these events have on food supplies and what impacts they will have on people day to day? Kylie or Maria, feel free to drop in. Again, I know potentially the impacts that we're seeing with hail as well as flooding, devastating potential crops, and that not only leads into food insecurity, but also food prices. Have you seen this much in your own reporting?
Yeah, I can start and then pass it over to Maria, but I definitely see food systems is such a huge part of climate coverage. And I do think farmers are surprisingly willing to talk about what they've been experiencing. I'm in New Jersey right now, and there's been a lot of issues with like milder winters and then frosts with cranberries and northern blueberries. So that's just something, and you can also see it reflected in food prices oftentimes. So that's something that all of your readers are going to be experiencing. Like everybody's talking about egg prices right now. This happens with a lot of agricultural products. So yeah, I think that talking to these farmers, but also talking to consumers about what they've been experiencing and getting into the why of these things is so, so important. And there's more trickle down effects than you would think once you start reporting on it.
Yeah, I can share that. My research isn't really closely tied to the agriculture sector, but I have attended outreach events with folks that work in the agriculture sector and have their own farms across the state of Maryland. And I was at a really interesting event a couple of years ago where I got to listen to some of their firsthand stories on some of the effects that they've been personally experiencing, right? And these are issues for them in having to insure their crops, other such considerations about how they're planning for the growing season and how that growing season is changing. And something I hadn't even quite known about until hearing some of these stories firsthand was even things like sea level rise and saltwater intrusion entering into certain systems and causing more issues. So again, I think this is a great place for not only scientists to work in more closely and continue to do outreach with folks that are directly impacted by such events so that we focus our research on those such topics and that have real impact directly to people now, but also for storytellers and the media such as yourselves that can tell these stories so that others are more aware about it as well. And yeah, we're all in this together and we need to move forward as
Yeah.
a team.
And one more thing on this, like I've heard similar things, Maria, and I also think like right now it's really crucial to cover what's happening with the Trump administration and how it could affect a lot of these farmers. So for example, there's been a recent purge of a lot of data on federal sites, climate data specifically, and farmers are not happy about this situation. So that's one story that's happening right now where they're not able to access this data. And there's so much chaos at the moment that it can be difficult to, like, I'm finding it difficult to figure out what to zero in on. So you can only do so much. And it is really important to have so many journalists, like those of you listening, who can cover each part of this chaos and try to make sense of it for the sake of readers. And farmers are a huge topic at the moment, I know, especially in New York. So just to give some story tips.
And I think that's a great way to kind of wrap everything up because once again, in all of this craziness that we are seeing, it illustrates how important it is for us as journalists to highlight what is happening on local levels, to offer solutions to what we can do to mitigate the worst impacts of climate change. Even if federal instances are lagging, what we can do at the local scale, at the citywide scale, and the statewide scale as well. And also to, again, prepare for the season's anticipated climate-driven events. That's just about all the time we have for today. I'd like to personally thank not only all of you for joining us, but also the wonderful panelists that we have joining us today, Dr. Maria Molina and Kylie Price. In addition, I'd like to thank our colleagues from from Climate Central for joining us here at Covering Climate Now for collaborating and presenting this essential climate information for you all. Really important. If you have any additional questions after sitting and digesting what we just talked about today, or if we had any questions that we didn't have time to answer, reach out to us. And we're going to be holding a virtual office hour tomorrow between 1:30 and 2:30 Eastern Time with myself, with Shel Winkley, as well as another colleague from Climate Central, where we can dive into some of those local impacts and those local numbers that we might not have touched too much on for today. And again, maybe just drop in to impart some fresh ideas for climate coverage in spring weather, and definitely continue to reach out to us here at Covering Climate Now and Climate Central. It's just a great chance to brainstorm, ask questions, and connect. You can go ahead and register via the link in our chat. From us here at Covering Climate Now, and for the TV folks present, we just saw a link dropped in the chat there. I want to let you all know about our Climate Station training program. Over the past year, reporters, meteorologists, producers, entire newsrooms, and local television stations across the country have benefited from this free training sessions designed specifically to help you talk about the local impacts of climate change in your market. To learn about this program, offered again completely free of charge for local newsrooms, head to our website or send myself or my colleague Elena Gonzalez an email. That's david@coveringclimatenow.org or elena@coveringclimatenow.org. We'll hope you'll join us again with us here at Covering Climate Now and Climate Central for our next Prep Your Climate coverage session. That's going to be all about summer's anticipated climate impacts, whether that's extreme heat, hurricanes, as well as wildfires. That is going to be coming to you later in May. Keep an eye out for that. And as I said before, keep in touch, follow us on social media, as well as sign up for our newsletters. Thank you again for your time today. Keep up the great reporting, and we'll see you soon.